The broadcast is now starting. All attendees are in listen-only mode.
Good morning. I'm going to get started in just about 5 minutes. Thank you for showing up a little bit early and get everything ready. There will be no further announcements or discussion from this side until we are ready to start, and that's in just about 4 minutes. Hello, and welcome to the second in a series of webinars on Quality 4.0, the Next Generation Technology webinar series. If you could please raise your hand if you can see my screen and if you can hear me. Great, we've got a lot of people out there that are raising their hands. Thank you very much for that. If you haven't raised your hand yet, would you please, so we can make sure that you're seeing what's the presentation and also hearing the narrative that goes along with it. All right, well, we're going to get started. Today's topic is how automated shop floor data collection can improve your quality process. Before we do that, we're just going to get a couple of housekeeping items out of the way. The first being that the webinar is going to last approximately 45 minutes, including the Q&A at the end. If we're unable to answer your questions before the end of the webinar, we will send you an email with a response shortly thereafter. Today's presenter is Sam Golan, founder and CEO of HiQA. Sam has a quite extensive background in a number of manufacturing-related industries, including CAD/CAM, PLM, metrology, and IT. And it includes Cimatron and Smart Team, which is now part of Innovia Dassault Systems. And with that, I'm going to turn the presentation over to Sam so he can give you the information you're all here for. Sam, here you go.
Okay. Let me just make it smaller here so we can run. Thank you, Jack, and thank you all for joining our webinar about data collection as part of the series of Industry Quality 4.0 webinars HiQA is performing. Our first webinar was about automated ballooning with all required downstream preparation, where we shared one of the most important steps to make parts right, eliminating user GD&T interpretation from 2D prints. We also shared how the loop closed in generating automatically reports, FAI, PPAP, and other formats. And at the end of the day, we make reports. We do not make parts. Well, although most or all of you agree with me about this statement, I will say no more. Quality role or quality departments are no more go, no-go department. We should, and we can bring much more value today if we just stop consistently running after our tail to deliver quality results and reports on time, as known the bottleneck at the organization. We better initiate the change, otherwise, as behind as quality industry is from other industries, quality 4.0 is not about to force the change, it is already started. And I hope that you will see how this change can happen through today's webinar. But before, let's take a quick refresher about the industry. Before we take a quick refresher on the industry revolution, let's take a quick overview what the manufacturing industry is promising us. So the good news that the manufacturing industry is growing, and it's growing very, very rapidly. Let's take a quick look on the aerospace and the automotive industry. For the aerospace industry, 400 parts, from 400,000 parts for the 737 series to 6 million parts for the 747-800 series. So now each one of the 747 is like 15 times 737 by part making or parts making. So what the future is telling us about new models. Speaking about the automotive industry, as you can see, a standard car has about 30,000 parts. Hybrid, double it to 60,000 parts. And the autonomous car is going up to 80,000 parts and more. If you look into your cell phone, it's done and completed every 20 seconds, but we keep it only for 2-3 years and waiting for the next model. I think we are in agreement, and we believe that outsourcing is not going back to insourcing by the OEM. The future for the manufacturing is really, really bright. But with this great news, there are many new challenges added, and actually they are continued to be added frequently. Parts getting smaller, much more complicated, very high precision, new materials coming to the market, new regulation, higher quality standard increase, and not less important, we require now to have it in shorter delivery time or just in time with lower cost. And what can we do? Growing competition domestically and globally. So let's take a quick look, kind of a refresher about what happened in the last 4 revolutions or industry revolution. Industry 1, first revolution that started at the 18th century to the 19th century, started with the innovation of the water and steam. It brought human activities from focusing on agricultural family demand to industrial society. The demand for industrial product in 1.0 has only one dimension, product volume, and mainly agricultural. This is a very simple market. It's based on demand, of a very small demand from or in your neighborhood. Industry 2.0 started at the end of the 19th century, and it's up till the last century, call it the 1980s, is when electricity developed to support mass production. It was the period when industrial products rapidly grow in both volume and variety. And major technological innovation included electricity, electronic, mechanical devices, aviation, and car developed. And we are still using those inventions even today. The industry 3.0 that started from the 80s and until today, I think it's characterized by technological innovation such change from analog to digital, which had huge impact, creating modern electronic industry. The product change from integral to modular, and the product size increased, product size smaller and increase, of course, capability. And this was associated with dramatic reduction in average product life cycle, of course. And the demand change and increases to volume, variety, and delivery. And now we are in 4.0. And this innovation or initiative came from government and large industries. It associated with the Internet of the Things. We all heard about it, big data, smart factory, and all related Internet activities and data sharing and security. But the biggest question is, are we ready? Or is the quality industry is ready for the 4.0? So here is an image for the smart factory. The illustration shows that once someone pushes the start button, everything is connected, shared, automated, synchronized with seamless flow and minimal human intervention. Well, I think the biggest question for quality, can we be part of this automation? I mean, we can add multiple questions when we talk about data collection. Where does the data collection fit here? Why do we need to collect data? How we are collecting data today? What do we need to do with the collected data? Why do we need it? And what is the value, if at all, does the data collection provides? Not just for the individual, but to the entire manufacturing process, of course. So there are probably much more questions that you will add to my questions, but let's try to move on and see what happened. Our part is in production, and let's say we have 5, 6, 7, 8 operations to make the part, and we need to collect the data for the following, let's say, process inspection for certain operation, which is done on-site. Let's talk about few operations that we need to collect data that are done outside by suppliers like plating or other activities. We need to create or generate SPC data for internal analysis. Of course, final inspection, we have to create reporting, SPC data because our customer requires, and the list is long and much, much longer. So there are hundreds of inspection tools, tens of thousands measurement tools, from manual to Bluetooth, wireless, CMM, vision, arms, laser, and the list is long and is growing daily, as you probably know. And the biggest question is not about measuring the part right, but where this data goes. Either it is written on a piece of paper, or typed into Excel, or clicked by a Bluetooth device, or by CMM, vision machine, arm, or by other hundreds of inspection tools we use to measure average part from start to finish. Well, there is another layer of data collection that become more and more popular, and this is SPC. And I believe that you all heard about it or already got much more familiar with it or maybe using it. Statistical process control, known as SPC, is an industry standard methodology for measuring and controlling quality for manufacturing processes. SPC is growing demand by OEM from their suppliers, and it is adding a significant burden and cost, of course, that required additional expertise and usually another software solution package, among many others that are already part of the quality processes. And here we have the same question: where this data goes and what benefit it provides. So it is not just about, generating data. It is about quality and trusted data. It is about integrated, synchronized, and analyze the data from multiple resources and tools. Yet, it is not about the data. It is about valuable information that you can use to make decisions, improving not only the quality process, but the entire manufacturing process. And this is where we can start eliminating the notion that quality is just go, no-go department. By the way, it happened, I think, a couple of weeks ago. We visited one of a large OEM business partner, and through the meeting, he stated the following, and I'm trying to quote: "I have a lot of data, but I don't have information. My data is spread all over the places in endless software system, folders with a lot of hard copies as well in boxes, reports, plans, in process inspection, results, SPC, engineering changes, you name it. But what conclusion I can get out of it? Nothing." And what he said, "My hope is that I don't need to get after customer complaint or auditor for data because I'm going to spend 2 weeks to find it." Sounds familiar, I believe, although I cannot hear you. So let's take a visual tour about data collection, but let's maybe try to do it right, hopefully this time. This graphic represents, in a high level, the entire quality industry problem, or on the positive side, the solution. Data collection, either internally or externally from supplier, is not a standalone solution. It is a part of a process. So, not just part of a process, it should be seamlessly integrate with every step, with all data stored in one cohesive database where it is automatically analyzed and consistently provide valuable information. And where it all starts, in 2D print. And 2D prints are here to stay for many years, despite of the new fashion about 3D model-based definition, as known as an NBD, or 3D model-based inspection, known as an NBI, and there are many MBs that are buzz the market. Spending more than 20 plus years in the 3D life as a co-founder of a CAD/CAM company and more than 10 years in the quality industry, I am still skeptical about 3D with PMI's value. Related to quality, it will definitely go there, but I'm still skeptical because there is not much value it provides right now. But we will devote a complete seminar about MB, ID, whatever the case is in the near future. So back to our drawing. Today, I don't know how much is going to surprise you. 70% or more of the industry still using pen or pencil to balloon their print manually, pen and pencil. And this is a conservative number. The quality requirements are also extracted and interpreted manually, then entered manually into an Excel spreadsheet with many other related quality steps along the way that quality required. And there are many things that I need to add here to really do a complete inspection process. How can we apply in-process inspection? Can we do it here? What about SPC here? How we can do something here, if any? How do we handle inspection data coming from the shop floor? Where it will go? How it will synchronize? Is it valuable to assign inspection tool, which is already calibrated directly to the feature that we are going to inspect in this stage and not get it, guessed by the user? And there are multiple activities in the quality processes, but it's done with different systems, different people, different stages, generating a lot of data, but hardly valuable information. And that is why the perception, as you probably heard from me more than one, that quality department might stay as go, no go, but we need to move it away from this notion. So let's start to look in it from A to Z, but probably and hopefully in the right way. So how about getting 2D print? You push the button and automatically get all quality requirements as a complete bill of characteristics with no human interpretation stored in the database. This is the first and the most critical step for the entire quality process. And by the way, for the manufacturing as well. If the interpretation is wrong, we could have additional 5,000 inspection tools measuring the part wrong, with the assumption, of course, that the manufacturing is the part right, but that's another topic for a webinar. The message that we are trying to convey is starting with 2D print, either vector, raster, whatever it is, converted to digital data, stored in centralized database, gives us a trusted, consistent data to use for upstream and downstream processes. And once a drawing is converted to a digital data and stored in a database, then we can build all other required quality activities on top of that. Each step will add another layer of information based on the same consistent data. Here in this example, you can see that you can apply in-process inspection, including ability to adjust nominals and tolerances relevant to this step. And again, I don't want to get into this in much more deeper, but trying to give you the idea how critical is to start the whole process right. The whole idea is to establish here all needed quality requirements for downstream and upstream easily and intuitively. This is the place where quality department can start changing the notion. Okay. Back to one of the questions we asked earlier, how important it is to have feature inspected using the right calibrated inspection tool by an authorized department or a person without individual interpretation, how I'm going to inspect this feature. Having the option to have integrated tools and gauge management as part of your quality system is the key, as inspection tool is an integral part of the quality process. Collecting data should have it as well, of course. So I think, and I believe that it is clear why all this is shared, because it's all about data collection. And data collection should be not just collected, but trusted. And maybe here, another layer of downstream preparation, we talked about SPC. And SPC, like CMM or gauge inspection, requires a setup plan for us to collect valid data. The question is how SPC data can provide trusted information, how it can be integrated as not another standalone software that create another island of information. In this example, right after the extracted data from 2D print, now all SPC can be set up based on the required feature with all the CPK and PPK and AQL table probably you see on the screen. And all this can be set up ahead of time, okay, including lot management and sampling, etc. Well, it's all done at the starting point. This ensures that in this case, SPC data and all other quality requirements are integrated, stored in a same centralized database, analyzed, and provide real value, real time, as needed. So finally, let's talk about data collection. I believe we are all on the same page about where the source of data collection comes from. And I hope we will be able to answer ourselves if this is really providing value and not just collecting data. What you see here is the concept we discussed. No matter what the inspection device is, and no matter what platform, PC, tablet, all the collected data are integral part of all what we have prepared in the quality process, like SPC requirement and other quality requirements. That is why, let's call it all-in-one, connected, synchronized, analyzed, stored in one location, and provides real-time valued information. Let's look practically on how it can look or should look. This is a tablet or user interface, but it can be installed on any PC as well. Either you will use it as a touch screen or with a mouse. The tablet is a subsystem from the product of a whole process downstream and quality preparation I shared earlier. And it's, of course, all integrated under the same centralized database. If you can look into the screen, there are kind of three categories. IM Express, purely data collection with no decision or choice by the user. IM Explorer for inspector and decision makers who can have a broader view and decision on shop floor data or status about data collection. And there is IM SPC for real-time data analysis providing by the SPC with, of course, a lot of ability to do trigger alert based on results. If we are clicking on the IM Express, it is very straightforward application. User will log in by name and password, or will scan the badge, and even fingerprint to log in. Once logged in, the user has a very clear yet limited menu. What you see here, in this case, are two inspection project assignments describe bar, part name, work order, serial number, and what operations are involved in this specific process. A job can be selected using the blue, you see select button there, or by scanning a part barcode if it is available. So once job is selected, we are now in a real life screen. We are getting project drawing with very clear step-by-step measurement requirements ready for data entry. Now look, the system guides the inspector through the process, leading him from one dimension to the next, keeping the right sequence if required, as sometimes measuring by certain sequences a must. Once the measurement results are entered by using the numeric pad or clicking on a Bluetooth or wireless device, data is automatically sent and stored in the database and available real time for any purpose, including real-time SPC, of course. And there are other information on this screen, like visual results by the results bar, the results color bar, if you can see below. And we can see also maybe two additional topics on that. As you can see here, there are inspection tool category automatically assign the tool if we would like to. And then if the tool category, for instance, change to a gauge tool, you can see on the small screen below right, tag entry to pass failed when you talk about gauge. Another item you can see below, the system can enable, you can see it in red on the main screen, the system can enable instruction on how to inspect feature based on new tools, new requirement, or other reasons. For example, we are now standing on 22.1_4. The system will automatically show the instruction as required before, probably you can see at 22.1_4, it shows me how I'm going to inspect this feature before it allows me to put the data in. And this is, of course, setup that can be done in a different ways, of course. So, sorry, we'll go back here. So when the inspection is completed, the dimension are all grayed out, all the data, of course, is stored, synchronized, and the user has nothing to do here. It's kind of a dead screen, like a kiosk for him. If we are clicking on the IM Explorer, as you see here, scored in red, there is a much richer capabilities and availability for the user. And if you look from the left to right on the top menu, you can look on for recently open jobs. You can scan barcode to enter a specific job. You can find job part by number, or you can visually browse the project. And if you're going to click on gallery search, as I'm doing here, what you're going to get is a very rich data connection to the database, showing you all the projects that you are able to access to. And then you can browse in between the project, and you can see here on the right side the relevant information that you should and you can see. You, of course, can select it, you can scan it, you can print it, you can assign it. There's a lot of action that you can do here. This is another way to look into it, not on the project level, but not on the part level, on the project level, and so on and so forth. And when we talk about the second layer of the menu item for the IM Explorer, talking about data collection, you can see the wildcard search from the left, the quality dashboard. You can print labels, barcode, etc. And you can set up alerts based on the assigned project, based on quality, based on tolerances. There's a lot of options that the call it the IM Explorer user can do. And let's click on the dashboard. And clicking on the dashboard gives you a very nice status view. And in this case, this is about a part project specific. And you can see here from left to right, the total dimension, talking about specific part, what inspected, what passed, what failed, and how many, if at all, non-conformance are going to be established. And the other view that you can see here is not on a part level, it's on cumulative job status. So you can look here and you can see on the right side as well, the job, the lot size, and you can see here the cumulative results or the status like total sampling, the inspected samples, the past samples, the failed, and so on and so forth. So that's what you can do and much more when we talk about data collection that are available to you real time. And maybe the last part of it is the data collection for SPC. The good news, the SPC set up at earlier stage. So it's automatically harvested and all the data is available with nobody and no one needs to do anything. No need to upload it anywhere. It's already automatically available. And in this case, what you see here, showing the data collection results based on the CPK and PPK we set up earlier, including the analysis a little bit to the right about capability and stability. And maybe the next view takes you even deeper. And this is much more detailed view based on what we have done at early stage on the drawing level, entering SPC inspected feature requirement. I believe this is showing you the value on how data collection can become valuable information if downstream preparation is done right, where SPC results, in this case, is connected all the way back to the ballooning data we generated at the beginning of the process. Valuable information is based on smart data collection, where all is connected, integrated, and real-time analyzed under one centralized database. And now comes the easy part. We know that's the easy part. Printing report should be no more a big project for copy-paste or manual clicking or modifying. It is automated outcome of data collection presented in different formats and generated with one click of a button at any time. There is no need to spend time here. Reporting should be available at any time, any format. And remember, we should get out from go-no department. And I hope I could share with you kind of the history, the challenges, and what can be done in the quality industry, really being ready for the 4.0 revolution or quality industry change for 4.0. But it's all about automation, eliminating interpretation, and valuable, trusted data collection. And with that, I will say thank you and return it back to Jack.
Thank you, Sam. Now, if I just want to ask everybody to send their questions in. if you have any at this point. I know we've got a couple that came in to me during Sam's presentation, but I'd like to hear from anybody else that has some questions for us. Sam, one of the questions came in deals with sharing the SPC and inspection data with ERP systems. Can you talk a little bit about how that's accomplished?
It shouldn't be an issue at all, because I don't want to say all, but most of the non-ERP having API, and our solution having, of course, API as well. So integration with ERP or any enterprise system is very straightforward, and we definitely can integrate with ERP. We are integrated today with a couple of ERP systems, of course, but we definitely can export data to ERP system as well. The question will be, again, which I asked in this webinar, is the value. Okay, let's transfer data or SPC data to ERP system. What we want to get there? What is the value we provide? I believe there is, but this is something that, you know, we like to ask our, you know, partners and customers by integration, by any level, what is the value that we provide to the user? But it's definitely can be done.
We have another question. Can you import discus files?
Yes, we can.
Okay, it's a very short answer, but very appropriate. And then I guess we've got a few more minutes for one or two more questions. Let me look down the list here for a second, see what we can get done in that amount of time. When you're talking about the data collection, IME and IMX, are these available, you said, on both a desktop or a tablet? Is there a recommended use for that? I mean, would a tablet be better than a actual desktop computer? Or how does that operate most effectively on the shop floor?
There is really no difference between them two. It's really depending on how you set up your shop floor, but it is completely identical. You know, tablet is more mobile, so if you need to run, you know, for a distance to collect inspection result in the warehouse, it's going to be very challenging to take PC with you all the way. But again, it's completely based on what are your quality requirements and how you would like to collect data. And because it's really identical in terms of functionality and capabilities, and they are both connected to the network, there is no difference at all.
Okay, and a follow-up to that, Sam, do you support iPads or just Android tablets?
At this point, we are supporting Windows tablets, but probably in the future we'll support other brands, probably Android before iPads. Okay, but right now it's Windows based.
All right, and then can you export to Net Inspect?
Yes, we can.
And let's see here. How would the Tulip shop floor data collection system integrate with HiQA?
It's the same system. So when we collect data, it's not a separate from HiQA. It's under the same database. So anything that you get from the shop floor, either from CMM, Vision, whatever inspection tools, data is brought in automatically into Inspection Manager database. So it's not different. And by the way, even when you get data from supplier, the way you communicate with supplier, which is another topic, then data can be brought in directly into the database because it's one brain, if I can call it this way.
All right. And with that, I think we'll, wait a second, did something else. Here we go. We got another question just came in. Is the data from the CMM directly linked to HiQA? Is this through PCDMIS?
No, it's directly to HiQA. PCDMIS or any other inspection device that generate digital data, the format that they are generating, mainly three formats. It's CSV, XML, or text file, and we support all three of them.
All right, thank you. And thank you everybody for attending the session today. And for more information, you can contact us at info@hiqa.com. Visit our website at hiqa.com to schedule a one-on-one demo, or you can call us at 888-727-1266. Once again, thank you for attending, and look for an invitation to our next in the Quality 4.0 series. Thank you.